All right, guys, quick video for you today. We are going to quickly go over scientific notations. So, why do we have this scientific notation? You may have seen this before in other science classes, but if you haven't, here's what we need to know. Some numbers are really, really big. Others are really, really small. And when we get really, really big numbers, it takes a lot of zeros. We're talking billions of billions. Anything or really, really small, something that's a fraction of a fraction of a fraction of an inch is a really, really tiny number. And it takes zeros both ways to do that, just to make it, just because those zeros are placeholders. If I have something that is let's say 25 trillion, and that is 1, 2, 3, 4, 5, 6. We're at million, we're at billion, and now we're at trillion. It took me so long to write all of those zeros outwards. And say if I have a very, very tiny number, it'll take 0.0000. 1, 2, 3, 4, 5, 6, 7, 8. That is a 9 nanometers. It's a very, very small distance. And why do I need to take all that time to write all those zeros? So scientific notation is just a shorthand way of writing really big or really small numbers. How do we do it? Start by moving the decimal place in the number until you have a coefficient between 1 and 10. That means the number out in front needs to be between 1 and 10. So we start by finding the decimal. And if there is a 1, we'll put it where it would normally be, like in 165,000. We know the decimal's right there at the end. And we're going to move this decimal once, twice, 3 times, 4 times, 5 times in this case. And now I'm going to move it so I have 1.65000. We're going to drop any non-significant zeros. What do we mean by non-significant? Well, take a guess. Do we really need to write the 1.65000? No, those zeros are non-significant. But zeros in the middle would be significant, and I'll do you an example of that in a moment. So we drop those end of the zeros. The number of places that you had to move is now your new exponent, and we are going to rewrite this as 1.65 times 10 to the what exponent? Well, we had to move it 5 times. 1, 2, 3, 4, 5. 5 spaces, so this is 10 to the 5th. If we move to the left, the exponent is positive. We got big numbers. That's what we did here. We moved to the left direction. If we move to the right, then we're going to have small numbers. So let's do it for this other one. I'll clear you. All right, for this guy, we are going to move the decimal 1, 2, 3, 4 spaces. So now I have 2.468. And all of those initial zeros, I could write it 0.0002. But why do I need to write all of those zeros? Unnecessary. 2.468 times 10 to the, how many spaces did I move? 1, 2, 3, 4 spaces. But I went to the right. I have a very small number here, so make sure that is a -4. Anytime we have negative exponents, we're talking about really tiny numbers. Anytime we have positive exponents, we're talking about really big numbers. So make sure you get that negative correct. But that's pretty much all there is to it. A couple examples right here that we can do some conversions. If I have, my formatting got off here, that's okay. Do this first one. If I have 6,514.045, how am I going to do this? I'm going to move my decimal 3 spaces. So I have 6.514045. Notice I did not lose that 0 because it's significant. It's in between other numbers. But if it was at the end, then we could have lost it. And I multiply this times 10 to the, how many spaces did I move? 3. So really not that useful when we have just regular size numbers in the thousands or in the millions. But once we get into really large numbers, say, or really small numbers, take this one, for example. I'm going to move this decimal 1, 2, 3, 4, 5 times. So I have 6.458. We count how many times did I move it? 1, 2, 3, 4, -4. And that actually ends up saving us some space here. I'll let you figure out these other ones, or maybe I'll just, if you want to pause and figure some of these ones out, you are welcome to right now. But then I'm just going to go through and do all of them. So this one should end up being 1.32 times 10 to the 1. This should be 1.54814 times 10 to the -3. This way we got 8.5 times 10 to the 7 times 10 to the 7. And this should be 1.20854 times 10, what? To the 0, because we didn't move this at all. And if what is times 10 to the 0? Well, 10 to the 0 is just 1. So we're just multiplying that times 1, and we just get the exact same value. So that one is a little tricky, but that's how you do all of these values.